Hey guys, Mr. Mackey here. Now yesterday I was showing you stem and leaf diagrams and I set you the challenge to create a box plot from this information. Now the first thing we need to make this box plot are we need to know what the lowest value is, the highest value is and what the three quartiles are. So let's get on with it. So our lowest value is 3 because that is at the very top. So I'm going to put 3 here. And with that our highest value is 42. Now from this we can find our median. So let's do some crossing out. So I'm sorry if that d is getting annoying. Just now it's between 19 and 20 because we have an even number. So what we do, we add them together. Then we divide them. So the median in this case is 19.5 or 19.5 or 39 over 2, all the same thing. Now from this we can find the median, the quartiles from the halves. So cross them out. 1, 2, 3, 4, 5, 6, 7, 8. Now it's between 13 and 14 for the first quartile. Add them together, halve them. So the first quartile is 13.5, 13.5, 27 over 2. Again, same thing. Now let's do the second quartile. So, oh, it's between 28 and 29. So what do? We add them together, we halve them, which gets us our third quartile of 28.5, 28.5, 57 point over 2. I'm losing track here. Well, what we know is that those are the answers. Now that we have this information, we can create a box plot from this. So let's get rid of this stem and leaf diagram and let's get the layout of a box plot sorted. Now this is a rough version of the box plot. You might have done yours a little bit differently on some squared paper, but this is how I've drawn it. And as you can see, I've labelled the whiskers 3 and 42, and I've labelled the quartiles 13.5, 19.5 and 28.5. And you can actually see there is quite a bit of spread inside the box plot, a little bit of a skew from the lower quartile, much more of a spread between the upper quartile and the median. But this is how your box plot should have looked. Fantastic if you did that. Now we're going to be looking at one final version of laying out data today, and it's a more interesting version because we're looking at relationships. Not relationships as in, oh yeah, I love you, because you know, lockdown. But relationships in more the sense of how one event can influence another event. And these could be anything. Now when we use relationships, we create things called scattergrams. Now let's create one now. Let's get into it. Now scattergrams are the best way to show a relationship because from them we can identify things known as correlations. We'll get onto correlations in just a minute. The important thing we need to do first is create a scattergram. Now scattergrams are obviously very similar to line graphs that we've done before, except we do not join the points together. That is a big no-no. We do not join the points together, okay? The reason why is because the points will make themselves, we'll get a correlation from just looking at the points. We don't need a line to prove it. Now this is our x-axis as per usual and this is our y-axis. Now let me explain the scenario. A school proposes that their scores in maths tests will influence their scores in science tests. So people who do better in maths will do better in science and vice versa. And they decided to create a scattergram using their 6 random results from pupils in their class. So let's create the scattergram. So X is for maths and Y is for science. So let's do it. So the first one we have starting off from 3, so over here, and we go to 7, which will be there. The next one is 5 to 6, so 5 there, 6 will go to there. Next one's 11 to 14, so 11 here, 14 is there. Next one is 12 to 13, 12 is here, 13 is there. Next one is 20 to 19, 20 here, 19's up there. And finally 7 to 9, 7 here, 9 there. That's all plotted. Now from this we can notice, it may not be obvious because of some next to each other, but they are going up in this direction. This is known as a positive correlation. A positive correlation means that when one event can positively influence another event. Like in this case, a positive correlation means that maths scores will result in an increase in science scores. That's what a positive correlation means. Now, positive correlations can range from very strong, which are when all the points join together to make a very strong line, but they could also be quite weak, so they're much more spaced out and it's not as obvious. This is a fairly strong positive correlation. So we can conclude from this that maths scores, an increase in maths scores, will lead to an increase in science scores. Let's look at another one. So scientists have been wondering if watching TV could influence scores in maths tests. So they got 6 people and asked them to do a maths test out of 20. They also asked them what the total number of hours they spent on that weekend watching TV was. And they created a scattergram from it. Let's see what they found. So, the first person spent 14 hours watching television and they got 6 marks in their maths test. The next person spent 16 hours watching television and they got 5 marks in their maths test. The next person spent 19 hours watching television and got 3 marks in their maths test. The fourth person spent 2 hours watching television and got 17 in their maths test. The next person spent 8 hours watching television and got 8 in their test. And then finally 3 people with 15 marks. That's a little bit higher. Now from this we can see a very clear line which is descending over time thanks to these results. This is known as a negative correlation. This correlation means that as something increases, the other will lead to a decrease. So for this, the more hours you spend watching television, the lower the marks you will get in a maths test will be, and vice versa. Let's check out another one. So, another group of scientists got 6 random people to do a maths test out of 20. They also asked the people to measure the length of their hair in centimetres, and then asked them to write that down as well. Now, from this, let's see if we can create a scattergram. So, if someone got 5 in the test and a length of 6, so that can go here. Next person got 9 with a length of 12, that can go there. Next one got 13 with a length of 11, that can go there. Next person got 19 with a length of 17, that can go there. Next person got 16 with a length of 13, that can go there. Final person got 4 with a length of 4, that will go there. Now from this we can see still quite a positive correlation from this. So according to this scattergram, the higher your maths score is, the longer your hair will be. So here is your challenge for today. Can you identify a problem with scattergrams, correlations and relationships in relation to what we have, bad choice of words, relation, in relation to the puzzle we have just cracked? Can you find a problem with them? Why does the idea of increased maths scores leading to longer hair length be a bit weird? Why? Let's see what you can find. I'm looking forward to seeing what you're going to say. Let's bring on more correlations for tomorrow. Good luck and take care, guys.